students. Now I'm going to take third lesson. Okay. From this third lesson, I'm going to take topic after 3.4, that is 3.5. Okay, because already Sir discussed the topics up to 3.4. So therefore, I'm going to take next topic. Right. The topic is magnetic effect of electric current. Right. So what is magnetic effect of electric current? See that when a current passing through a conductor, magnetic field produced around the conductor. Yes, again I'm telling, when the current passing through a conductor, magnetic field produced around the conductor. Yes, this is the magnetic effect. Clear? Or other words I'm telling, if you are take one small conductor, or for example copper wire or rod. Okay, so the same time I'm going to apply a small amount of current. For example, 1 ampere of current pass through the copper wire. So around that copper wire or around the rod, what will produced? Magnetic field is produced. Clear? So this is the magnetic effect of electric current. Okay. Yes. See that magnetic effect of current. What is that magnetic effect of current? See that an electric current produces magnetic effect in the space around the conductor called strength of magnetic field. Which one? Strength of magnetic field, or simply we called magnetic field. Yes. So this effect explained by Oersted experiment. So Oersted is a scientist. So he explained the magnetic effect of current through experiment. So this is the simple experiment, right? So this is what battery, and one is rheostat, and this is magnetic needle, and this is the key. Okay, so the current flow from positive to negative. So this is north pole. Okay, and this is that direction of current opposite. Now, so this experiment, when the current allowed to flow through a wire placed parallel to the axis of magnetic needle kept directly below the wire, so the needle was found to be deflect from its normal position. The same time, see this one, when the current was reversed through the wire, the needle was found to deflect in opposite direction to the earlier case. Just see this. So the direction of current here from south pole to north pole, that means positive to negative. You can see the deflection. And the same time, when the current flow is opposite direction, you can see the deflection. So this is the magnetic effect of current, right? That means when the current flow through the conductor, around the conductor, a magnetic field is produced. Okay, when you change the direction of current, the magnetic field direction also changes, right? Next, see that. So this is one conductor, either copper or any metals conductor. Around the conductor, what will produce? Magnetic field is produced when the amount of current flow through this conductor, right? So that is magnetic field lines around the straight long wire carrying current. Okay. Yes. Same time, see that this is what cardboard. Yes. In this cardboard I'm going to put two hoses, and through the hoses I'm connecting the one copper coil. Yes, that is loop. It is a coil. This coil connected to battery. Yes, one end is connected to negative terminal of the battery, another end is connected to positive terminal of the battery. When the current flow through the coil, around this individual coil, what will produce? Magnetic field is produces. So this is magnetic lines around each holes. See that the magnetic field lines curling around the circular coil carrying current. Yes, so previous case straight conductor and this case for circular coil. Okay, see, this is the direction of magnetic fields, anti-clockwise direction. But if you go to this side, clockwise direction, magnetic field lines around this coil in which direction? Clockwise direction, right? Next, magnetic effect of electric current. See, this is one straight conductor. Around the conductor, what will produce? Magnetic field produce. Okay, and this is the direction of current from downwards to upwards. Yes, see this. If we hold the current carrying conductor in our right hand such that the thumb points in the direction of current flow, the thumb point gives the direction of current flow, then the fingers encircling the wire points in the direction of the magnetic field lines produce. Okay, so the thumb finger gives the direction of current and the fingers are gives the direction of magnetic field, right? So from this diagram, this is that conclusion, right? Yes. At the same time, magnetic effect of current, yes, from this diagram, Maxwell's corkscrew rule. Yes, Maxwell's corkscrew rule. So what is Maxwell's corkscrew rule? See the diagram. See that this is the conductor. So direction of magnetic field around the conductor and direction of current. Direction of current from upwards to downwards. The direction of magnetic field around the is conductor like this. So therefore, come to this one, Maxwell's corkscrew rule. State that the direction of magnetic field in the same as the direction in which you would turn an ordinary corkscrew to move it in the direction of current. The direction of current. So ordinary move in the direction of current. So clear? This is which rule? Maxwell's corkscrew rule. Again I'm telling. So according to this rule, the direction of magnetic field, yes, the direction of magnetic field in the same is the direction. Yes, see that Maxwell right hand corkscrew rule. See that in our book, this is the diagram. So this is the direction of magnetic field. So this is the direction of current. So which one? The thumb finger gives the direction of what? Current. And this is the direction of what? Fingers, this remaining fingers are direction of magnetic field. And this one is that rotation of the screw. This is Maxwell's right hand corkscrew rule. Yes, at the same time, followed by Maxwell's corkscrew rule to determine the direction of magnetic field. Yes, that rule is Ampere's rule. That is Ampere's swimming rule. What is Ampere's swimming rule? See the diagram. A man who swims in the direction of current from south pole to north pole facing a magnetic needle kept under him such that the current enters his feet, then the north pole of the needle will deflect towards his left hand. Yes, at the same time towards west. Just see that. So just imagine. So just for imagination from north pole and south pole. Clear? When the current flow like this. Okay. This is Ampere's swimming rule. Now come to the Maxwell corkscrew rule or right hand screw rule. Both are same. Yes, Maxwell corkscrew rule or right hand screw rule. Yes, this is one screw. The direction of current from outwards, the current here inwards. The direction of current, you will see that the direction of current anti-clockwise direction and here clockwise direction. See that again I'm telling, if the forward motion of an imaginary right-handed screw is in the direction of the current through a linear conductor, then the direction of rotation of the screw gives the direction of the magnetic lines of force around the conductor. Magnetic lines of force around the conductor. This is which one? Maxwell's corkscrew rule. Do you understand? Okay. Yes. The same time, the next one is right hand thumb rule. That is curl rule. Okay. So we call right hand thumb rule followed by the magnetic effect of current. See what is right hand thumb rule? Just see this. The thumb finger represents the direction of my current and the fingers are representing the direction of magnetic field. Yes. Now come to this one. If a current carrying conductor is imagined to be held in the right hand such that the thumb points in the direction of current, then the tips of the fingers encircling the conductor will give the direction of magnetic lines of force. Okay, this is right hand thumb rule. Okay, this is important. Which one? Question. Okay, now come to that. Yes, which one? Next important question. This is 3 mark, at the same time important 5 mark. Yes, Biot-Savart law. Which one? Biot-Savart law. The law alone 2 mark question. Now come to this law. The strength of magnetic field, that is dB, due to the small current element dl. So this is the small current element. So this is a small current element carrying a current I. Yes, so this is a wire carrying current I at a point P, distance r from the element is directly proportional to I. That's why I'm telling one by one. So the magnetic strength, magnetic field is directly proportional to the which one? Current, that is I. At the same time, this magnetic field is directly proportional to the S element, that is which element? See that dl. At the same time, the magnetic field is directly proportional to the sine of angle. Which one? Sine of angle. That is which one? Sine theta. Which one? Sine theta. And the last one is the magnetic field is inversely proportional to the square of distance. Which one? Square of distance. That is 1 by, see the last one, 1 by r square. And here theta is nothing but angle between dl and r. The angle between element and this r. Okay. So the magnetic field is directly proportional to current and directly proportional to element length and directly proportional to sine of angle between them and inversely proportional to square of distance. So from these 4 points, yes, I'm concluding dB is directly proportional to I dl sine theta divided by r square. I is current and dl is element, sine theta and is sine of angle and r square. Yes. See this one. So this is the point. From r distance, this is one straight conductor. This is small element length. So if I'm using S equal, I'm going to use one constant. Yes, it is proportionally constant. Therefore, that constant is K. K value is nothing but mu naught S divided by 4 pi. Mu naught divided by 4 pi. Yes. So minus mu naught divided by 4 pi, that is constant, proportionality constant. Okay, and mu naught I dl sine theta divided by, yes, this is whole divided by 4 pi r square, 4 pi r square. Okay, yes, continuation, vector form. See that the same dB which is equal to mu naught I dl vector into r vector. So r vector is r cap, that is unit vector, divided by 4 pi r square. If sine theta is equal to Yes, sine theta is equal to 90 degree. What is the value? 1. Okay, that's why I see that dB is equal to mu naught I dl into r and divide by 4 pi into r cube. Yes, the value of mu naught converted in free space though is equal to 4 pi into 10 power minus 7 Tesla meter ampere power minus 1, or otherwise Weber meter, yes, power minus 1 ampere power minus 1. Yes, the same time the direction of magnetic field, the direction of magnetic field in the same as the direction of dl vector into r vector, which can be determined by the which rule? Right hand screw rule. What is right hand screw rule? The screw rule gives that the thumb finger gives the direction of current and fingers are represent the direction of what? Magnetic field. Yes, and this points emerging at P and entering, yes, P into the plane of the diagram. So the current element is a vector quantity whose magnitude in the vector product of current and length of small element having the direction of the flow of current, that is IDL. Okay, yes, followed by this one, right hand, that is Biot-Savart law. Important question: magnetic field due to a long, yes, straight conductor carrying current. Yes, that is the topic. This is the important 5-mark question. Magnetic field, yes, due to a long straight current carrying conductor. Okay, so see that figure number 3.39, magnetic field due to a long straight current carrying conductor. So which is the conductor? So this is the straight conductor. Mn is the straight conductor. Okay, the midpoint of the conductor is O, right? And in this conductor I'm going to take small element, that the element is dl. Okay, from the midpoint of element A, from this one, the same time from this one I'm going to consider one point P at which distance? A distance. So therefore just I'm joining the element. So this joining create the angle, that is what? Theta. So therefore the distance between the center point and this center point of the element is L. Okay, and from the distance A to P is nothing but R. Okay, Mn is which one? Straight conductor. The midpoint of the straight conductor I'm taking O. From this point I'm consider point P. Yes, at which distance? A distance. So when the current flow this conductor, around the conductor, what will produce? Magnetic field is produced. That's why magnetic field due to a long straight current carrying conductor, right? Okay, so please understand, dB is what? Magnetic field. Already we know that from Biot-Savart law, magnetic field around the conductor dB is equal to mu naught I divided by 4 pi dl divided by r square into sine theta. Yes, into sine theta. Okay, from that first triangle PAO, yes, from that triangle like I'm telling, yes, PAO, where is PAO? PAO, yes, from which one? PAO. From this is the one triangle, and another triangle is, see that, PAM. So this is also another triangle. Please understand, POA. So this is one triangle, another triangle PAM. So from this triangle I'm calculating. So the, yes, come to this one. So first triangle PAO, tan, yes, which is equal to pi minus theta. What is pi minus theta? 180 minus theta, which is equal to A by L. It's equal to A by L. So because sine, yes, 180 minus theta, which is equal to minus tan theta. Which one? Minus tan theta. So therefore from this one I'm taking L go to, yes, L go to this side, L which is equal to A divided by tan, yes, 180 minus theta, that is pi minus theta, which is equal to A by minus tan theta, because 180 minus theta is equal to tan theta. Therefore L which is equal to A by tan theta. At the same time, if you are separately 1 by tan minus tan theta or 1 by tan theta is equal to cot theta. Therefore, L is equal to minus A cot theta. Minus A cot theta. This is equation number 1. Okay. The same way, if you go to that second triangle, I already said PAO. From the PAO, sine, which is one, sine pi minus theta, 180 minus theta is equal to A by R. Which one? A by R. Yes. Now, sine 180 minus theta which is equal to which one? Sine theta. Therefore, from this one I am going to take R this side, which is equal to A by sine 180 minus theta, which is equal to A by sine theta. Therefore, A by sine theta, if I am taking R is equal to, come to this one, A by sine theta. If I am taking 1 by sine theta, that is equal to cosecant theta. Therefore, if I am taking R which is equal to A cosecant theta. Do you understand? A cosecant theta. This is equation number 2. Now, from the equation number 1, I am taking L which is equal to minus A cot theta, right? So, differentiating with respect to theta, what will come this side? dl by d theta, which is equal to minus A, the same. Cot theta, if I am differentiate, what will come? Minus cosecant square theta. Therefore, dl which is equal to, this d theta come to this side. A cosecant cosecant square theta into d theta into what? D theta. That is equation number 3. So now come to this initial equation dB which is equal to mu naught I divided by 4 pi. Now come to the dl. What is dl? A cosecant square theta into d theta into sine theta into which one? N cap, and divide by A cosecant theta square, right? Because R square, no, from that one. Okay. Now, if I'm simplify, what will come? Mu naught I divided by 4 pi. So what will cancel here? A square, because A square A, and cosecant square, and that's all. And remaining what will come? Sine theta into R cap. So what will remaining? Finally, dB which is equal to mu naught I divided by 4 pi A, because A square remaining A. So what will come here? Sine theta into d theta into R cap. Yes, this is that. Which one? Magnetic field around the current carrying conductor. dB which is equal to mu naught I divided by 4 pi A into sine theta into d theta into R cap. R cap is that unit vector representation, right? Okay. Yes. Now, next one, magnetic field due to a long straight current carrying conductor. Okay. Yes. For understanding purpose, please listen. The same one by one I'm telling. See that? Same one. So please listen. Again I'm telling, because this is very important question. That's why I'm telling. dB is equal to mu naught I divided by 4 pi dl divided by r square into sine theta. Yes, from the triangle, which triangle? PAO, I'm taking tan 180 minus theta A by L. Therefore, L is equal to A divided by tan 1 pi minus theta, which is equal to A divided by minus tan theta, because tan 180 minus theta is equal to minus tan theta. So from that one, L is equal to minus A cot theta, because 1 divided by tan theta is equal to cot theta, right? So this is the diagram. The second triangle PAO, which is equal to sine 180 minus equal to A by R, and R is equal to A by sine 180 minus theta. Sine 180 minus theta is equal to sine theta, therefore A by sine theta. From this one, R is equal to, here 1 by sine theta is equal to cosecant theta, therefore R is equal to A cosecant theta. The second equation. Yes. Again come to this one. From the first equation, yes, L which is equal to minus cot theta. So here I'm going to differentiate with respect to theta. Therefore, dl divided by d theta is equal to minus a into minus cosecant square theta, because d by d cot theta divided by d theta is equal to cosecant square theta. Therefore, dl which is equal to a minus into minus plus. Therefore, a cosecant square theta into d theta. This is equation number 3. So this equation number 3, substituting equation number this one, because dl no. Therefore, I can get dB vector which is equal to mu naught I divided by 4 pi, and a cosecant square theta into d theta divided by a cosecant theta whole square into sine theta into which one, r cap. Okay, so therefore I am simplifying. Here a square, a cancel, a remaining, and here cos square theta, here cos square theta cancel. Therefore, finally what will come, sir? dP is equal to mu naught I divided by 4 pi a and sine theta into d theta into r cap. Do you understand? So this is very, very important question. That's why I'm telling. Okay. Important 5-mark question from the final formula, important 1 marks. Magnetic field due to a long straight current carrying conductor. Okay. Yes. Next, if the straight wire is infinitely long conditions, then pi 1 phase pi 1 and pi 2 is equal to pi by 2. What is pi by 2? 90 degree. Please substitute the value in sine theta. B which is equal to mu naught into 2L divided by 4 pi a. The same 4 pi a will come. Here pi by 2, this is 90. Or otherwise mu is equal to, here if you simplify 2, 4 cancel, you will get mu naught I divided by 2 pi a. Both are same. Just we are substituting the angle 90 degree, you will get this equation. So both are same. Okay. Now another condition is, see that the direction of magnetic field is the same as the direction of SDL into R, which can be determined by the right hand screw rule. Now see that it is perpendicular to the plane of diagram and entering to the S plane at P, the magnetic flux around the conductor. Please then, so the right hand is rules. The current is entering from bottom to is top. Therefore, the right hand rule like this. The magnetic fields around the conductor in which direction? Anti-clockwise direction. Now come to this one. When the current flow from top to bottom direction of the conductor, magnetic field is produced. The direction of magnetic field produced in which direction? Clockwise direction. So that time the S right hand screw rule like this. Okay. Yes. Next one. Now I'm going to take circular coil. So previous case straight conductor. Now this case current carrying circular loop using Biot-Savart law. So here I'm taking circular coil. Which coil? Circular coil. What is circular coil, sir? See this. This is one circular coil. Okay, in this circular coil I'm taking small element, right? Okay, circular coil, this circular coil carrying current, right? Okay, I'm going to consider a point P is at which distance? R distance from the element. Which distance? R from the element. So this is the TL element from the element. Okay, so both are perpendicular. The magnetic field around this circular coil, see that 90 degree, and here also 90 degree. Okay, this is circular coil, and this is one triangle. This is which triangle? One triangle. This is also another triangle. Here theta value is nothing but what? 90. Okay, the magnetic field produced along the axis of the current carrying circular coil. Current carrying circular coil, right? So just this is one. So this is one circular coil carrying current. Yes, I'm considering a point P. around the axis of the coil, right? Okay. See that in that point P, yes, I'm dividing is two components. One is sine component, the sine component acting along is which one? Horizontal way, and cos theta acts in the axis of the coil. Okay, so this component making angle, that is d theta, and here also what? Theta. Now according to Biot-Savart law, dB is equal to mu naught divided by 4 pi and IDL into r vector divided by r square, right? Therefore, if magnetic field, therefore I'm going to integrate B with C to integral dB which is equal to dB cos theta into yes k cap. Okay, so here integral mu naught, because dB value, what is dB value? Mu naught divided by 4 pi IDL vector into r vector divided by r square. Therefore, just we are substituting this value. What will come? Mu naught divided by 4 pi into I into S d q, sorry, dl divided by r square into cos theta into k cap. Okay, and again mu naught I divided by 4 pi taking outside, remaining integral dl by r square into cos theta into k cap. Okay, do you understand? Yes. Come to this one, cos theta. Cos theta is equal to, from the red triangle, OD divided by dP. OD divided by dP. OD is nothing but distance between the axis of the coil and the point, that is R. So divide by, from dP from the triangle, yes, R square plus Z square 1 by 2, because dP is nothing but for example is that a square which is equal to r square plus z square. If I'm taking a alone, what will come? Yes, root. If you cancel the root, what will come, sir? 1 by 2. That's why r square plus z square into 1 by 2. Okay, now come to that yes question. We already simplified this equation. dB is equal to mu naught I divided by 4 pi and integral dl divided by r square into cos theta. No, instead of cos theta I'm substituting r divided by r square plus z square 1 by 2 into k cap. So because r square is equal to z square plus r square, do you understand? So therefore mu naught I divided by 4 pi integral dl divided by z square and r square into r divided by r square plus z square 1 by 2 into k cap. Okay, again if I simplify mu naught I divided by 4 pi, this r square divided by z square plus r square into 3 by 2, here also what will come? Here 1, so here 1 by 2, what will come? 3 by 2. So remaining integral dl into k cap. Okay students, yes, continuation. So is equal to mu naught divided by 4 pi r divided by z square plus r square 3 by 2 integral dl into what? K cap. So again mu naught divided by 4 pi, yes, I'll tell you r divided by z square plus r square 3 by 2. Here if I'm integral, yes, dl, yes, differentiating, sorry, integration dl which is equal to L. So L is 2 pi r. What is circumference of the coil? So therefore 2 pi r. If I'm substituting instead of dl, what will come? 2 pi r. So here 2, 4 cancel, pi cancel. Therefore 2 remaining, what will come? R into r square, and divide by h square plus r square into 3 by 2 into k cap. So finally B vector which is equal to mu naught I divided by 2 into r square divided by r square plus z square 3 by 2 into k cap, right? So this is that magnetic field around the circular coil. Yes, around the circular coil. Do you understand? Okay, students, just I'm repeating. So from that Biot-Savart dB is equal to mu naught divided by 4 pi IDL into r square divided by r square, and b which is equal to integral dB which is equal to s integral dB into cos theta into k. So just substituting dB value is equal to s mu naught divided by 4 pi into I d theta divided by r square into cos theta into k, and it's equal to mu naught divided by 4 pi, and remaining integral dl by r square into cos theta into k. Okay, so from that triangle cos theta, the cos theta value, so that cos theta value substituting in previous equation, line integral dl divided by r square into cos theta. So instead of cos theta, substitute this value and substitute the r square value, and you will get this equation, and you will simplify, you will get this equation mu naught divided by 4 pi into r square divided by z square plus r square 3 by 2 into dl k vector. So from that one, if you simplify, you will get this one. So in integration dl is equal to 2 pi r, because integral dl is equal to l. If you are integrating l is the circumference of the what? Circular coil. Therefore substituting l, you will simplify, you will get final equation b which is equal to mu naught I divided by 2 into r square divided by r square plus z square whole power 3 by 2 into k cap. Okay. The same one. So please then, so that is handwritten notes. Now again the same question. dB which is equal to mu naught into ideal sin theta divided by 4 pi into r square, or dB is equal to mu naught divided by square. Okay. So the angle between theta between dl and r is 90 degree, because the radius of the loop is very small. So since the sin theta is equal to 1, the same way, if dB is resolved into two components, I already said, one is cos component is cos pi, and another one is sin component. Due to the diametrically opposite current element, cos component is always opposite to each other. So therefore, hence we cancel out of each other. So therefore sin components, due to all the currents, dl get added up, so along the same direction. That's why I'm taking b which is equal to integral dB into sin pi, because sin angle only added, the cos component will be acting in opposite direction. That's why cancel to each other. So therefore dB sin pi which is equal to, just substituting the value according to Biot-Savart law, mu naught I dl sin theta divided by 4 pi r square. If I simplify, b is equal to mu naught I 2 pi a divided by a, so into a divided by 4 pi, just a square plus x square into a square plus x square 1 by 2. So if I simplify, you will get mu naught I a square divided by 2 a square plus x square whole power 3 by 2. Okay. Yes. Come to the cases from the circular loop. For cases at the center of the coil, it x equal to 0, instead of x you have to substitute what? 0. So what will remaining? B is equal to mu naught I divided by 2a, because x is square, so x will be 0, the remaining thing will be 0, that's why 2a. Suppose if the observation point is far away from this coil, so a is lesser than x, so a square can be neglected in comparison with x. Therefore b which is equal to mu naught ia divided by s2x cube, right? 2x cube. Just we are substituting the values in the previous equation, you will get this one. Okay. Yes. And just for understanding purpose, different views of direction of current and magnetic field due to the circular loop coil. See this, the current entering this coil from this direction, bottom to top, and see the current is direction around the holes. Now come to this one, the current entering like this and leaving from this, therefore the magnetic field lines around the circular loop. Okay, students. And see the second one, the current loop, same equations, same one. Sorry, yes, for simplification of second one, current loop. Suppose the current loop like this, the plane of the coil is lying on the plane of the diagram and the direction of current in clockwise such that the direction of magnetic field is perpendicular and into the plane. Suppose this is the cases, the magnetic field at the center of the loop, circular loop, what will come according to Biot-Savart law, dB, which is equal to mu naught into I dl sin theta divided by 4 pi a square. Okay, just here substituting the value in sin 90 is equal to 1. So what will remaining? Mu naught I dl divided by 4 pi into a square. So dB alone, integral dB, which is equal to, already we know that dB is equal to mu naught I divided by 4 pi a square. So ideal, yes, if you are taking outside mu naught 4 pi a square outside, and what will remaining? Integral I into dl. If you are I also outside, what will remaining? Line integral. What is line integral? dl, element length. So therefore that element length is nothing but what? Circumference of the coil. So if I am integrating dl, I can get L. So L is the circumference of the coil. Therefore 2 pi r, instead of r, the distance is a. So therefore 2 pi a. So if you are substituting 2 pi a in this equation, I can get, yes, in numerator 2. So therefore 2 4 cancel. I can get mu naught I divided by, what will come? 2a, because here a square, here a, so a cancel. I can get finally mu naught I divided by 2a. So this is what? Final equation for circular loop for our case. Okay, students. So two detailed questions we discussed. One is magnetic field around the state conductor. Another one is magnetic field around the circular coil. These are two questions are very important. At the same time, the final equations of two questions also very important. Yes, just see the videos slowly and then understand. Okay, students. Okay, students, today class is over. We'll see you on next video. Okay, at the same time, I'll give you homework. Please study the magnetic field around the which one? State conductor, that question. Okay, please study the magnetic field around the state conductor, that question. It is an important question. That is your homework. So please study. Okay, because tomorrow I'll give you test from this topic. That's why. Okay, students. Okay, thank you.